Hi everyone, welcome to Corridor. The next question of Lead Code Contest 381 is count the number of houses at a certain distance. One. So, what is the question stating is that you're given three positive integers n, x, and y. In a city, there exist houses numbered from 1 to n connected by n streets. Okay, so there is a street connecting the house numbered from I with the house numbered I plus 1 for all I ranging in 1 to n minus 1. Additionally, there are street connecting the house numbered X with Y, house numbered Y. So for each K, such that K is existing between 1 to N, you need to find the number of pair of houses such that minimum number of streets that need to be traveled to reach house 2 from house 1 is K. Okay. So what is the question stating? Is that we have n number of houses, right? And every house ith house is connected to I plus 1th house. Simultaneously there is a path between both the houses. Okay, and there is also an extra variable x and y such that both those two houses numbers are also connecting with each other. Okay, so what do we need to return is that we need to return an array of element where the ith index value shows or tells the number of house pairs that can be traversed in that particular distance. For example, let's have the first example, that is 1 2 and 3 is the house numbers, and 1 is connected with 2 and 2 is connected with 3. Here we have x as 1 and y as 3, so x and y are also connected with each other. Okay, so how are we getting this result array as 600 is that for distance 1, that is for index 1 or k equal to 1, that is we are returning the number of pair of houses that can be traversed in only one distance. Okay, so what are the pairs? 1 comma 2 and 2 comma 1. So 1 and 2 and 2 and 1 house numbers can be traversed in only one distance, right? Similarly we have 2 comma 3 and 3 comma 2, and then we have 1 comma 3 and 3 comma 1. So there are total 6 pair of houses that can be traversed in one distance, and this distance is minimum. Okay, so we need to first find the minimum distance between all the pair of houses, and then we need to fill this particular array, right? So whenever we have this concept of minimum distance, we always think of the shortest path algorithm. So if you're familiar with the algorithm named as Floyd Warshall, so you'll be able to solve this particular question very easily. So I would suggest you first go through the Floyd Warshall algorithm first. So what does the algorithm state is that it basically finds the minimum distance that need to be traversed between 2 points. Okay, so for example, here we have 2 3 and 4. Okay, 1 2 3 4 5 are the numbers of houses, and we have 2 and 4, so there is an extra path between 2 to 4 directly. So either I can go from 2 to 3 and then 3 to 4, or I can directly go from 2 to 4, right? So there are two paths between 2 and 4, and there is an intermediator 3 between them. Okay, so what the Floyd Warshall algorithm does is that it finds the minimum distance between every two pair of numbers. Okay, so that is what it does. For example, if we have k as an intermediator and I is the start point and j is the end point, it will find the distance between ith and jth point by finding the minimum of distance of ij, that is the whatever the prior distance that we have, or distance of I comma k plus distance of k comma j, that is it is fine taking the intermediator. For example, if start is 2 and end is 4, right? So either it is the minimum distance between 2 comma 4 or 2 comma 3 and 3 comma 4. So basically it can be either 1 or 1 plus 1, that is we are getting. Okay, so whichever is the minimum it will consider that. Okay, so I hope you're clear with this. Coming back to the question, for example, if we have 1 2 3 4 5 as the house numbers, and here 2 and 4 are connected with x and y values, right? 2 and 4 are connected with x and y values. Okay, so how are we getting 10 over here is that what after getting the shortest path by Floyd Warshall algorithm. For example, if we have one length distance, so what are the house numbers that can be connected with only one distance. Okay, so for example, 1 comma 2 and 2 comma 1 is a pair, then 2 to 3, 3 to 2, 3 to 4, 4 to 3. Okay, simultaneously we'll get 10 pair of houses that can be reached in one distance simultaneously. When k is 2, that depicts the pair of number of pair of houses that can be traversed in two distance, minimum two distance. So this was the whole logic of this particular problem. We'll be going through the code. I would still suggest you people to first go through the Floyd Warshall algorithm. Then it is just an implementation of that particular algorithm. First we are doing x minus minus and y minus minus. Basically this depicts that we are converting it to a zero based indexing. Okay, then what we are doing is we are taking a distance vector and initializing every distance to be the max value first, and after we'll be iterating through this distance vector and filling this distinct grid. So what we are doing is first we'll initialize it to 0, and if there we'll see that uh, for every I, for example, for every I and I plus 1th house number, there is a path, right? So that is what we are doing. We are initializing its distance to 1, from I to I plus 1, and then again from I plus 1 to I. So these directions are not directed, right? They're undirected. Basically there is a direction from 1 to 2, and then again from 2 to 1. Okay, so that is what we are doing. And simultaneously there is another coordinate that has been given, that is x and y. So for that also we will be initializing it to be 1. And this is the implementation of Floyd Warshall algorithm, wherein we are taking a k element, that is the intermediator. Okay, intermediator, and I is the start point and j is the end point, and between every I and jth coordinate we are finding the minimum distance that we have, and at the end we will just push all the distances into our answer vector and will return the answer vector. Okay, so I hope you're clear with this approach. Thank you.